So, we're going to do number 7. And number 7, guys, remember, you don't have to follow along, but just keep it low enough so I can hear myself and so other people can hear me. Thank you. In number 7, they're asking us to add vector v1 to vector v2. But they give us it in this component notation. And that's one of the notations that we didn't do, but we can easily translate it to our own notation. So I'm going to transfer, first thing I'm going to do is translate the component notation to unit vector notation. You got that part? Okay. So the first component would be in the x direction, the second would be in the y, and the third would be in the z direction. So I'm going to convert vector v1 to unit vector notation to 2.1 and 10. So this is number 7, and I'm actually going to do it down here. So v1 had its first component was 2, so that would be 2.0 I, because I indicates the x direction, plus 2.1 j. Now remember, your numbers are going to be different than my numbers because those are in red, right? Okay. And then it had plus 10 in the z direction, which in unit vectors is k. To draw this vector, I need a 3D plane. So let's see. I'm just going to try to draw, see how my drawing skills are. There's a 2D plane. Let's see, so let's say x is in this direction, y is in this direction, and then z is upwards. Can you guys picture what I'm trying to draw? 3 dimensions there? Kind of. It's number 7. Yeah, I know. It's not the best drawing. Well, like this is a perspective of like a piece of paper. So like my hand. I'm trying to draw my hand pointing up that way and then Z coming up off of it. To draw this vector, I would draw, say, 2 in this direction, 2.1 in the J direction, and then up 10 in the K. So my actual vector, that would be that V1. That would be V1, that vector. And each of these, of course, would be a right angle. And let me do V2. Let me see what my V2 is. 2.3, negative 4.1, and negative 0.4. So V2, what was that? That's up to go. 3.3 is 2.3I minus, because it's a negative term there, negative 4 minus 4.1J. Of course, I could put that as plus negative, right? We all know that's just minus. And then minus 0.4K. That vector, if I draw it, I've got 2.3 in the x direction. That's going to be then I have to go negative 4.1 in the j, so I go back 4.1 this way, and then down 0.4. So it'd be like that. And my V2 vector looks like that. So it goes underneath my plane here. Yeah, because they're not points, they're lengths in those directions. So, like the first one says it's 2 in the x direction. Well, the 2 here is 2 in the positive x direction. So technically, you're right. I should have little arrows on each one of these. They're not right triangles, but they're right. You're right. Well, let's first add these together, okay? Then we'll figure out the length. Because I would move, what I would do is I would take, and I want to add B1 to B2, so I would take all my stuff for B2, and I'd arrange it tip to tail with B1, and then my final vector goes from the tail of one tip. Ugly, ugly drawing, right? Ugly, ugly drawing. So I would give credit on the vector diagram for this, of this. B1, B2, resultant. I would give credit on that because that's really ugly. It's correct, but it's really ugly. So I would, if you'd had this, I'd give credit for it. Okay, just to let you know. I'd give you credit too. As long as I look at it and say, ooh, they understand the weirdness that's going on here. And this shows me that you understand how to combine vectors. We are going to use the components, because now we're going to add these two together. And here's the nice thing, what do we call that? R, is with components, I can just add up my columns. So 2 plus 2.3 is 4.3. 2.1 plus negative 4.1 is negative 2.0. And 10 plus a negative 0.4 is plus 9.6. I just add down my columns. So there's my resulting vector, the components of my resulting vector. Right. So these I'm going to put in order. Those are my components. 4.3, negative 2, and 9.6. Let's see if I got them right. Yes, I did. But now I got to figure out the length. Is that what you were also wondering about? Well, I don't want to do another nasty drawing on you. So, because there's a form of something that I call 3D Pythagoras. We all know Pythagoras, right? A squared plus B squared is C squared. Okay? So if you have a simple triangle, A squared plus B squared is C squared. Well, if that hypotenuse of that triangle, which is the triangle that's in the XY plane, is the side of another triangle, then that becomes A. So A squared plus B squared is the new C squared. If you combine those into a 3D vector, you get what I call 3D Pythagoras. If you combine those, the hypotenuse of one of the right triangles is the leg of the other right triangle, which is the case for the three components of a vector. Then you get, they combine to be what I call 3D Pythagoras. Okay? To find the length of the full vector. And here's the form of, and you can look at that, here's the form of 3D Pythagoras. A squared plus B squared plus C squared equals D squared. So where 2D Pythagoras had 2 legs of a triangle, this has 3 legs of two triangles that are joined. All right? This is is on your equation sheet. Whenever they say find the length of this three-dimensional vector, and you know the components, you use 3D Pythagoras to do it. And so, at this point, I have my components. Bringing this up. It doesn't matter. It doesn't matter. Just like it doesn't matter which one's A or B in the triangle. Those three, the three components are the A, B, and C. So I'm going to have 4.3 squared plus negative 2.0 squared plus 9.6 squared equals my R squared. And I need to find R. Nope, you still add it because you square. And you actually could think of those as the magnitudes. So I should have probably written positive because length is always positive, right? But 4.3 squared plus negative 2 squared plus 9.6 squared. I get my R squared to be 114.65. But I don't want R squared, I want R, so I square root that, and I get 10.7. Let's see if 10.7 is correct. Your numbers are different. This one, you should either have it open on your phone or on one of the computers that isn't being used, so you can work in parallel. Yay, I got it correct. Yeah. All right, we're doing number 6 here. Delivery truck travels 20 blocks north, 17 blocks west, 21 blocks south. Of course, everything in red is different for every user, so be careful. I'm going to start off by drawing mine 20 blocks north. All right, so I'm going to take north as up. So I'm going to go 1, 2, 3, 4. Each of my blocks I'm counting as 5. So that's 20 blocks north, 17 west, 17. So this is 20 blocks. This is 17 blocks. And 21 blocks south. And this is 21 blocks. So I've got this little circle route. They want to know that. They want to know my displacement D. All right. So for me, it's in that direction. You know, what I'm gonna do is I'm gonna take, and I want to find the components of D. So I'm gonna draw D nice and big, and I'm gonna look and combine all my horizontal parts. I only have one horizontal part. That's pretty easy to combine, right? So my one horizontal part is 17. So this is going to have a horizontal component that's 17 blocks long. And now I need my vertical part. And if I look, I combine my vertical parts. I go 20 north and 21 south. So that means I end up 1 block south. Yes? Okay? So now, this, I'm going to be able to, oh, that's a right triangle. That's kind of cool, because those are the components. What I need to look at, they want to know the magnitude, so the length of that hypotenuse, and direction counterclockwise from east is positive. So if I kind of dot an east in here, they want to know all the way around like that. This may be where you have a problem. Yeah. I've got to start at east, which is this direction for me, and go all the way around till I come to my vector.
Opposites would it be west?
No, you always would start from east. Let me see yours. Oh, so yours points up. Well, if it pointed up, if mine pointed up like this, that would be a slightly different situation. So let me talk about mine, and then I'll talk about yours up here also, okay? I got the one block because mine had me go 20 blocks north, and then 21 blocks south. So north-south-wise, I end up one block south. That make sense? So first thing I did was combine anything that was horizontal together, and then I combined anything that was vertical. Yeah, the right-hand one. Yeah. So for me, I can only find angles that are inside the triangle, right? All right, talking to myself. So I can only find angles that are inside the triangles. So I can find this angle here, and we'll call that theta. But I need to realize the answer that they're looking for mine is 180 degrees plus theta. Now, if mine was the green, right? You mean yours is the opposite of green on your paper? It looks like the green. Oh. Yours is the same as the red then. East would be out here. I will show you, but trust me, yours is like this. I'll show you in a minute, okay? So now I need to do my triangle here, and I've got a right triangle. I know two of the legs. I want to know the hypotenuse, and I want to know this angle. So if I know the two legs of a triangle, what can I use to find the hypotenuse? A squared plus B squared is C squared. Good old Pythagoras. And so my A in this case, let's say, is 17 blocks. My B is 1 block. Oh, that'll be easy to square. I think I can do that one in my head. And then my C is, I've labeled D. Do you guys think you can do that math there? The D, to find D? Yeah? Okay. I'm going to move on to find theta then, because I think theta is the math that you guys will be a little shakier on. I want to use tan because I know the opposite of theta, right? Yeah. I want to do opposite over adjacent is the tangent of theta. So the tan of theta, and I'll move this up as soon as you see where I get the numbers from, equals the opposite side, in my case 1 block, over the adjacent side, 17 blocks. So I got those from the opposite side and the adjacent side. Now I want to move all of this down so that, a second. So the opposite side over the adjacent side. That's that little triangle, yep. To get theta out of my tangent function, I have to do inverse tan to both sides. Theta is tan to the -1 of 1 block over 17 blocks. So I'm going to find theta then after I do my math. I'm hurrying because the block's almost over. And my angle, my answer, for me, is going to be 180 degrees plus theta. Yours might be different depending upon your orientation. No. Make sure you're not in radians.